Okay, this is Mr. Asher, and this is finishing up the Module 4 in-class assignment for Chem 121 for winter 24 quarter. And so I think the only two that we didn't get to in class were number 27 and number 28. And number 28 is referencing a reaction that we didn't actually cover in class, so I'm not going to go over that, and you won't have to fill that out for the class. So that's sort of deleted, and I forgot to delete it from the problem set because we don't do the reaction at 28 anymore. It was causing mental anguish for everybody. But I'm going to do 27. So 27 is dealing with this beast again, where we had what? Sorry. Okay, so it is 2 KMnO4 plus 5 K2C2O4 plus 8 H2SO4 goes to and then let's see, 8, so it has to be 6 K2SO4s plus 2 manganese sulfates plus 10 CO2 plus 8 H2O. I think that's what I had down in the last thing, right? So this is the balanced chemical reaction. And the problem says I start with 546 molecules of KMnO4, 1,284 molecules of K2C2O4, and 2,206 molecules of H2SO4. And it says which and how many of the starting molecules are left over, and how many molecules of CO2 are produced. So let's start with the first part. Which and how many of the molecules are left over, okay? Or whether they're all consumed quantitatively, right? So remember, these coefficients sort of have units with them. And what they tell us is for the reaction, 2 moles of KMnO4 reacts quantitatively with 5 moles of K2C2O4, potassium oxalate, reacts quantitatively with 8 moles of H2SO4. Molecules, I'm sorry, molecules. Molecs, not moles, molecules. Sorry, I'm getting ahead of myself. Molecules, okay? And so if I want to know how many molecules it takes to react 546 molecules of KMnO4, I have to use these as unit conversions to convert molecules of KMnO4 into molecules of K2CO4. So I would start out with 546 molecules of KMnO4. And then I'm going to multiply it by something with units of molecules of K2C2O4 per molecule of KMnO4. Okay. And from this, you see that the coefficients, the numerical coefficients we put in here are the coefficients here. So it would be 5 molecules of K2C2O4 for 2 molecules of KMnO4. And what you find when you do that is you get, I'll get my calculator out, I'm already ready to do that. Is 546 times 5 divided by 2 is equal to 1,365 molecules of K2C2O4. Right? Well, what that means is that there isn't enough K2C2O4 to completely react all the KMnO4, right? Which means that K2C2O4 is limiting. And that's going to limit how much this here is going to limit how much KMnO4 is going to react, okay? Because I need 1,365, but I only have 1,284, which means that not all of this can react because I don't have enough K2C2O4, right? And now the next thing I have to do is to check whether or not H2SO4 is limiting. Because if H2SO4 is even more limiting than K2SO than the oxalate, then that's going to determine how much KMnO4 is going to react. So let's do the same thing for H2SO4. And we're going to get 546 molecules of KMnO4. And now the reaction is 8 divided by 2 molecules of H2SO4 or molecules of KMnO4. And that's 546 divided by 546 is 2184. So I need 2184 and I have 2206, which means that there's excess sulfuric acid, okay? So if I have excess sulfuric acid, that's good. It means it's not limiting. It means that K2C2O4 is the limiting reagent here, right? So now, so I've identified the limiting reagent. K2C2O4 is limiting, right? And that means I'm going to use up all the K2C2O4. And that means to figure out how many moles of CO2 I produce, I base it on the number of moles of K2C2O4 I start with. So I have 1,284 molecules, sorry, not molecules, moles, but molecules, K2C2O4. And then I'm going to multiply that by the conversion factor between CO2, molecules of CO2 per molecule of K2C2O4. And it's 10 molecules of CO2 per 5 molecules of C2O4, of K2C2O4. Well, 10 divided by 5 is 2. So I just have to multiply 1284 by 2. And I get 2568 molecules of CO2. Okay. Now that's the quick and dirty way. And it's almost always going to be pretty close to right. But you have to keep in mind that this coefficient here, that 5 to 2, there might not be an even number of K2C2O4s that will react into 546 molecules of KMnO4, right? So you have to keep that in mind. But for the purposes of this is a good enough answer. 2568 molecules of CO2 are produced. Okay, that finishes off the module 4 in class. I'm going to stop there and I will talk to you later.